Welcome to SS2 Further Mathematics, Term 3, Week 6. Standard integration formulae x, sin x, cosine x, e, 1/x are not sufficient for all integrals. Two powerful techniques extend our ability: integration by substitution, the reverse of the chain rule, and integration by parts, the reverse of the product rule. By the end of this lesson, you will apply integration by substitution with confidence, apply integration by parts including repeated application, and solve WAEC Further Mathematics examination problems. Let us begin. Integration by substitution is used when an integrand contains a function and its derivative, or a constant multiple of it. It reverses the chain rule. Basic pattern: if the integrand has the form f g x times g x, then integral f g x g x dx equals integral f u do where u equals g x. Step-by-step method: choose a substitution u equals g x, choose the most complicated part, often the expression inside a bracket, under a square root, or in an exponent. Find do equals g x dx, so dx equals do/g x. Substitute into the integral and replace all x's with u's. The integral should become simpler. Integrate with respect to u, substitute back x's for u's. Worked example 1, integral 2x, x superscript 2 plus 1, dx. Let u equals x superscript 2 plus 1. Do/dx equals 2x do equals 2x dx. Integral, x superscript 2 plus 1, times 2x dx equals integral u do equals u/6 plus c equals x superscript 2 plus 1 /6 plus c. Worked example 2, integral cos 3x plus 2 dx. Let u equals 3x plus 2. Do equals 3 dx equals do/3. Integral cosine u times the do/3 equals 1/3 sin u plus c equals 1/3 sin 3x plus 2 plus c. Worked example 3, integral x square root x superscript 2 plus 4 dx. Let u equals x superscript 2 plus 4. Do equals 2x dx x dx equals do/2. Integral square root u times do/2 equals 1/2 times 2/3 u caret 3/2 plus c equals 1/3 x superscript 2 plus 4 caret 3/2 plus c. Worked example 4, integral e caret 2x dx. Let u equals 2x. Do equals 2 dx. Integral e caret u times do/2 equals 1/2 e caret u plus c equals 1/2 e caret 2x plus c. For definite integrals with substitution, change the limits when you substitute. If integral f g x g x dx and u equals g x, then the limits change to u a and u b. Alternatively, carry out the indefinite integral and back substitute x before applying limits. Worked example 5, integral x superscript 2 plus 1 superscript 3 dx. Let u equals x superscript 2 plus 1 do equals 2x dx x dx equals do/2. When x equals 0, u equals 1. When x equals 1, u equals 2. Integral u superscript 3 times do/2 equals 1/2 times from 1 to 2 equals 1/8, from 1 to 2 equals 1/8, 16 to 1 equals 15/8. Trigonometric substitutions: for integrals involving square root a superscript 2, x superscript 2, square root x superscript 2 plus a superscript 2, square root x superscript 2, a superscript 2, for square root a superscript 2, x superscript 2 use x equals a sin theta square root a superscript 2, x superscript 2 equals a cosine theta. For square root a superscript 2 plus x superscript 2 use x equals a tan theta square root a superscript 2 plus x superscript 2 equals a sec theta. For square root x superscript 2 a superscript 2 use x equals a sec theta square root x superscript 2 a superscript 2 equals a tan theta. Worked example 6, integral dx/square root 4 x superscript 2. Let x equals 2 sin theta, dx equals 2 cosine theta d theta, square root, 4, x superscript 2, equals 2 cosine theta, integral, 2 cosine theta d theta, / 2 cosine theta, equals integral d theta equals theta plus c equals axin, x/2, plus c, standard result, integral dx / square root, a superscript 2, x superscript 2, equals axin, x/a, plus c. Integration by parts is the reverse of the product rule for differentiation. Product rule, d/dx equals u dv/dx plus v do/dx. Rearranging, u dv/dx equals d/dx, v do/dx. Integrating both sides, integral u dv equals uv, integral v do. This is the integration by parts formula. Also written as, integral u dv/dx, dx equals uv, integral v do/dx, dx. Choosing u and dv, the choice affects difficulty. Layet rule, order of preference for choosing u. L equals logarithm, I equals inverse trig, A equals algebraic, polynomial, T equals trigonometric, E equals exponential. Choose u from this list in order, whichever appears first becomes u, the remaining factor is dv/dx. Worked example 7, integral x e dx. Choose u equals x, algebraic, earlier in Layet than exponential, dv/dx equals ev equals e. Do/dx equals 1 do equals dx. Integral x e dx equals xe, integral e dx equals xe, e plus c equals e, x, 1, plus c. Worked example 8, integral x in x dx. U equals x, algebraic, dv/dx equals sin x v equals cosine x, integral x sin x dx equals x cosine x, integral cosine x dx equals x cosine x plus sin x plus c. Worked example 9, integral ln x dx. U equals ln x, logarithm, dv/dx equals 1 v equals x, integral ln x dx equals x ln x, integral x times 1/x dx equals x ln x, integral 1 dx equals x ln x, x plus c. Worked example 10, repeated integration by parts, integral x superscript 2 e dx. U equals x superscript 2, dv equals e dx v equals e. Integral x superscript 2 e dx equals x superscript 2 e, integral 2x e dx equals x superscript 2 e, 2 z e plus c equals e, x superscript 2, 2x plus 2, plus c. WAEC Further Mathematics Integration Questions Test, applying substitution to compute integrals of composite functions, changing limits for definite integrals with substitution, applying integration by parts, 1 application, occasionally 2 applications, repeated parts, recognizing when to use substitution versus parts. Special case, cyclic integration, when integrating e cosine x or e sin x, applying parts twice returns to the original integral on the right side. Integral e cosine x dx equals e cosine x plus e sin x, integral e cosine x dx. Let I equals integral e cosine x dx, I equals e cosine x plus sin x, I2 equals e cosine x plus sin x, I equals e/2 cosine x plus sin x plus c. This cyclic technique gives a result without infinite repetition. Key substitutions to memorize: integral f(x/f x) dx equals ln f(x) plus c, logarithmic integration. Integral f(x) n dx equals n plus 1 / n plus 1 plus c, power substitution. Integral e kx dx equals 1/k e kx plus c, integral sin kx dx equals -1/k cosine kx plus c, integral cosine kx dx equals 1/k sin kx plus c. Integration by parts results to memorize: integral x e dx equals e x 1 plus c, integral ln x dx equals x ln x, x plus c, integral x sin x dx equals sin x, x cosine x plus c, integral x cosine x dx equals cosine x plus x sin x plus c. Key points: integration by substitution, choose U equals inner function, find do, substitute, integrate, back substitute. For definite integrals, change limits when substituting. Trigonometric substitutions for square root x equals a sin theta for square root a superscript 2, x superscript 2. Light rule for integration by parts, L or log, I inverse trig, A algebraic, T trig, E exponential, U is the earlier one. By parts formula, integral U dv equals uv, integral v do, repeat when one application leaves another product integral. Cyclic integration, E cosine x, E sin x apply parts twice, rearrange to solve for I, memorize standard results, integral ln x dx equals x ln x, x plus c, integral x e dx equals e, x, 1, plus c, integral f slash f dx equals ln f plus c.